In most cases, you calculate the area of a triangle by taking half the base times the height. Here, we are going to discuss a method to find the area of a triangle using Heron's formula. Suppose we know the length of the sides of a scalene triangle are 6 cm, 7 cm and 8 cm and not the height. Can you still find its area? Definitely, if you want to apply the formula, you will have to calculate its height first. Try doing so. If you find it complex, there is another simple method to find the area of a triangle even without finding its height. Let's see how it is. Heron, a famous mathematician, derived the formula for the area of a triangle in terms of its three sides. The formula is known as Heron's formula or Hero's formula. The formula is stated as area of a triangle with the sides A, B and C is square root of S into S minus A into S minus B into S minus C, where S is called the semi-perimeter, that is half the perimeter of the triangle, and is given by S is equal to A plus B plus C by 2. Now, when to use this Heron's formula? This formula is helpful where it is not possible to find the height of the triangle easily. Let's see one problem using Heron's formula. Find the area of the equilateral triangle with side 10 cm and compare the result using the basic area finding equation. So the steps are, first we have to draw an equilateral triangle with side 10 cm. Now next find S, that is semi-perimeter using the sides given. Here we know that A is equal to B is equal to C is equal to 10 cm given in the question. So what will be the S? S is equal to A plus B plus C by 2, which is equal to 10 plus 10 plus 10 by 2, and we get it as 15 cm. Now find S minus A. S minus A is equal to S minus B is equal to S minus C is equal to 15 minus 10 is equal to 5 cm. Since A, B and C all are 10 cm. Now next step, apply its value in the Heron's formula. We know area of triangle is equal to square root of S into S minus A into S minus B into S minus C. Now substituting the values in the equation, we get square root of 15 into 5 into 5 into 5, and we get the answer as 25 root 3 centimeter square. Now come to the second part of the question, that is compare the result using the basic area finding equation. So we did the same question using the area equation. There we obtained the answer as 25 root 3 centimeter square. Hence verified the result. So the area we have got using base side is the same as we found by using Heron's formula. Now let's see what are the advantages of using Heron's formula. First, we don't need to find the height. Second, much simpler calculations we can do. Now let's see what are the applications of Heron's formula. Heron's formula usage can be extended to find the area of a quadrilateral. Area of a quadrilateral using Heron's formula. Suppose there is a quadrilateral having sides A, B, C and D and the diagonal R. We know the diagonal divides the quadrilateral into two triangles, triangle ABC and triangle ADC. Now find the area of each triangle using Heron's formula. So the sum of areas of two triangles is the area of the quadrilateral. That is, area of quadrilateral ABCD is equal to area of the triangle ABC plus area of the triangle ADC. Let's solve one example. A piece of cultivated land in the shape of a rhombus whose side is 100 meter and one of the diagonal is 160 meter. What is the area of the land? Given each side is equal to 100 meter. Now let diagonal AC is equal to 160 meter. So to find its area, divide the entire portion into two triangles by drawing the diagonal AC and find its area using Heron's formula. So we get two triangles, that is triangle ADC and triangle ABC. Now separately I have shown this for more understanding. For triangle ADC, sides are, let AD is equal to 100 meter, which is our A. DC is equal to 100 meter, let it be B. Now AC is equal to 160 meter, that is C. Now use Heron's formula to find the area of triangle ADC. What is a semi-perimeter? Semi-perimeter, we get it as 100 plus 100 plus 160 by 2, which is equal to 180 meter. Now substitute the values in the equation. Area of the triangle ADC is equal to square root of 180 into 180 minus 100 into 180 minus 100 into 180 minus 160. So we get area of the triangle ADC is equal to square root of 180 into 80 into 80 into 20, and on solving we get it as 4800 meter square. Therefore, each of them get an area of 4800 meter square as they both have the same side measurements. Area of triangle ABC will also be 4800 meter square. So, what will be the area of ABCD? Area of ABCD will be area of ABC plus area of the triangle ADC. So, we get 4800 plus 4800 is equal to 9600 meters square. Now, let's have a recap of what we have learned in this section. So, we know that in this we have learned what is a Heron's formula and its method to calculate the area of a triangle. Area of a triangle with sides A, B and C is calculated, and the area of the triangle is given by square root of S into S minus A into S minus B into S minus C, where S is called the semi-perimeter, where that is given by S is equal to A plus B plus C by 2. One can also recognize the reasons to use a Heron's formula and applications of Heron's formula.